It's been a week since a tornado touched down in Mirabel, and researchers have now found evidence of another weak tornado that took place near Saint-Thomas in the Lanaudière. No tornadoes touched down in Montreal, but the severe weather brought intense rain, flash flooding, and quite the lightning show. The same day in Ontario, a tornado touched down in the Ottawa suburb of Barrhaven as well, damaging at least 125 homes. Tornadoes are impressive. They can come on incredibly fast, and the damage can be extensive if they touch down. Today on the show, we'll talk about everything from how they form, how they're classified, and what people really need to watch out for. And we'll also touch on the psychological impact of these kind of natural disasters. We also want to hear from you. If you have questions about tornadoes, give us a call at 514-597-4500. Toll free again, 1-877-597-4500. Or you can send us a text message at 514-566-9066. Our guest for the hour is Djordje Romanic. He's an assistant professor in the Department of Atmospheric and Oceanic Sciences at McGill University, and his research is focused on thunderstorms and tornadoes. He also does research on how wind interacts with buildings. Welcome to the show.
My pleasure.
First off, I want to talk about what are the perfect ingredients for how a tornado forms? What does a tornado need?
Tornado needs a parent storm, and perfect ingredients for a thunderstorm in a form of supercell, these are the most powerful thunderstorms, is if we have unstable air, that's warm, moist air that's being lifted up. Now, mechanisms to lift that air up are complex, but most of them are associated with cold fronts. And these are cold masses of air colliding with this warm and moist air. And because cold air is heavier, the poor warm air has nothing to do but go up. And as it is going up, all that humidity and moisture is condensing, producing thunderstorm. And that thunderstorm then, if severe enough, has potential to cause tornadoes.
And does a tornado always come with a thunderstorm? Do they always kind of go hand in hand?
Yes. So in our atmosphere, the only clouds that can produce tornadoes are thunderstorm clouds, or technically speaking, cumulonimbus clouds. There are three types of thunderstorm clouds. There is single cell, multicell, and supercell. Most tornadoes are produced by supercell clouds. Some of them rarely by multicell clouds, and single cell clouds cannot produce tornadoes.
So those are, you're talking about these two kind of air masses that are meeting together. And it's funny that you should mention that, because we did see the temperature jumping all over the place on Thursday last week. It was 28 and then suddenly it was 21 degrees outside. Like the temperature was going all over the place. What causes the rotation that happens with tornadoes? Yeah.
So first of all, just to go back to your comment about temperature fluctuations, this storm past Thursday was actually associated with cold front. And after the storm passed, the temperature lowered down a little bit. So that, what you said, makes perfect sense, and measurements confirm it. Now, in terms of tornadoes, how does that rotation end up being close to the surface? Humankind currently doesn't have complete theory of tornado formation. Now, this is not to say we don't know anything about it. I'll say many things what we do know about it, but we cannot tell you with 100% accuracy, that cloud over there, that thunderstorm will form tornado, that thunderstorm will not form tornado. Generally, storm must have updraft, what I just said. There is this hot, warm air needs to go up. When the environmental wind conditions are favorable for that updraft to rotate, and when there is downdraft at the same time interacting with updraft, that downdraft can bring the rotation close to the surface in a form of tornado.
Interesting. And how fast are we talking that this can spin?
Yeah. So tornadoes, the cut-in wind speed, so to speak, for tornadoes, is 29 meters per second. So all tornadoes have winds stronger than 30 meters per second, let's say. And they can go over 100 meters per second. If you think about it, speed of sound is 330 meters per second. So that's 1/3 of speed of sound that extremely strong tornadoes can rotate.
Wow. Today we're talking about all things tornadoes, and we welcome your questions or your experiences with tornadoes. You can give us a call at 514-597-4500, toll free 1-877-597-4500, or send us a text message at 514-566-9066. I also want to talk about how tornadoes are classified. How does that classification system work?
So tornadoes are scary, but fortunately they happen rarely. And therefore, probability of a tornado going over weather stations so we can measure wind speed is very, very low. That almost never happens. And even if it happens, well, that tornado destroys equipment, anemometers, and so on. So the way we classify tornadoes is after tornado passes, unfortunately, it causes damage. But then engineers and experts from various fields can go and do damage assessment. And they say, look, this chimney was destroyed. I will do reverse engineering and tell you, well, the wind speed to destroy this chimney having this construction material and so on is such and such. So we use the so-called damage indicators to assess what would have to be damaged to destroy wind speed to destroy that particular object. And then we classify tornadoes from EF0, that's the weakest tornadoes, to EF5, that's the strongest tornadoes.
So it's only after the fact that we know how strong it was.
Correct.
Okay, so it's not like when hurricanes come, you can see them coming over the ocean, they can detect like how fast the winds are moving. It's always after the event has happened that we can figure out how strong they were.
Yes, because hurricanes are systems that are, it can be 1,000 kilometers. We see them through satellites, radars, and there is no way in today's day and age that hurricane just pops up and nobody was aware 2-3 hours ago that there was a hurricane. Now, in case of a tornado, they're very localized. Average diameter of a tornado is 200 meters or below, even below 200 meters. And as I just said, we don't have complete theory of their formation. So we can see storm coming, but we cannot say with precision whether or not that storm will cause tornadoes.
And how hard are they to predict then?
Well, I mean, impossible to predict. We do not give weather forecast for tornadoes. We give likelihood. So if there are ingredients, as I said, if there is a particular change of wind direction with height, if there is instability, if we see that storms are approaching, and these storms are severe, and there are parameters like storm relative helicity, CAPE, all kinds of some technical parameters. If these parameters are in the red zone, then there is high likelihood of tornado or medium likelihood of tornado forming. But we cannot really say when tornado will form, how long will last, even less how strong it will be, and what will be particular trajectory that it will take.
So how sensitive is Environment Canada then to kind of putting out these, either warnings or watches? Like, what are they basing it on, and how often do we see this happening now?
So they base that on severity of storm. They can see it through radars. Radars are a big help in atmospheric sciences in these severe weather analysis and forecasting. So we can see readily storm approaching. If the environmental parameters, these technical parameters I talked about, if their evaluation is such that there might be a chance for tornado, they issue warning. Now, if tornado is spotted, then warning is right away issued. The thing is, quite often there is a warning and then there is no tornado. Mm-hmm. That's because better safe than sorry, mm-hmm. right?
Yeah, so you see this as a good thing. That if it doesn't come, this is actually good news.
Of course. Because tornado can cause death. In the worst case scenario, injuries and a lot of destruction. So it's better to prepare for something like that. And if it doesn't happen, well, better than not being prepared and then all of a sudden you get shocked.
Mm-hmm. I want to talk about the destruction that tornadoes can cause. What are the 3 ways, I guess, that tornadoes can cause damage?
Yeah. Tornadoes produce the strongest winds close to the surface out of all other natural phenomena. But strong winds are not the only way of tornadoes damaging structures and the environment. The other 2 ways are suction, namely very low pressure in the center of tornado, and flying debris. And for humans, particularly dangerous is actually flying debris.
Why so?
Well, because speeds of these flying objects can be 50, 60, 70 meters per second. Now, if you just look around you, if you're listening this, and find some random pipe or a wooden plank or something like that, and now imagine that thing is flying 50 meters per second. find distance 50 meters and then traverse it in 1 second. And now imagine a laptop that is in front of us hits you in head. Well, not good.
No, definitely not good. Yeah, so this is the reason why when there's these warnings, like how seriously should people be taking this when they see these warnings? What should they be doing?
So these warnings should be taken as seriously as possible. And if you are, of course, in-house, go... if you're not in-house, go and find shelter. If you are in an apartment, a house, then generally you should go to basements. Most houses should be designed to even if the house collapses, the basement should be able to withstand the collapsed building. Now, if you are outside, that's really not good. And now I could sugarcoat it here. And the best thing you can do is to try to find some small valley or something and lie down and hope for the best. At least you are a little bit protected by flying debris. Mm-hmm. You're not protected from high winds. You're not protected from suction at all, suction pressure, negative pressure. But at least, hopefully, you get some protection from flying debris in that small valley.
Yeah, we sometimes see during tornadoes that people are on the highway or something like that they sometimes try to get under like an overpass or something where there's concrete that can block part of it, but try to find some shelter of some sort, Yes.
Now, if you are outside at that time, there is another thing you should be worried about. It's not just tornadoes, it's lightning. Lightning is a nasty phenomenon. Of course, if it hits you, then most likely, again, you will not survive or you will have very severe injury. So this is, and of course, often tornadoes come with hail, size of a tennis ball or something, and that's also not good. So you should not be outside during a thunderstorm.
It was funny, when the storm hit last week, we can't see directly outside, but we could certainly see the lightning flashing, and I don't think I've ever seen it like that. It was like flashing nonstop in the windows behind us. Today, we're talking about all things tornado. Obviously, we had those tornadoes that touched down in the Ottawa area and as well as Mirabel last Thursday. And we're taking all of your questions about tornadoes or your text messages. You can call in at 514-597-4500, toll free at 1-877-597-4500. And on the text line, you can send us a message at 514-566-9066. So the group that is studying tornadoes right now out of Western University is called the Northern Tornadoes Project. And their aim is to kind of better detect the occurrence of tornadoes in Canada and to improve severe weather prediction. How are they going about doing this?
So that's a very nice initiative from researchers over there. Maybe a small background to this project is in the United States of America, they are monitoring very seriously tornadoes since 1950s or so. Okay, so they have very good database of how often tornadoes form and what is their strength. In Canada, we didn't have that until, I don't know now, 5-6 years ago, let's say. So we had, of course, a database, but it wasn't seriously investigated. So there was a belief there are approximately 80 tornadoes per year in Canada. But after this project, when people seriously started looking at it, we see now there are at least 100 tornadoes. So what this group of researchers is doing is they, first of all, if tornado is spotted, if people report tornado, they go and they investigate damage. They fly drones to see what is exactly the damage pattern, width, length, all these things. Now, if there is a suspicion there was a tornado somewhere, they can look into satellite images and see if there was any damage after the event compared to satellite image a few days ago. And then, if suspicion is high enough, they can still go there, investigate. So we get much better quantitative assessment. How many tornadoes, how strong, where they occurred, how long they lasted compared to what we had many, many years ago.
And we have a caller on the line, Dalia. Go ahead with your question.
How do they break stuff if there are only clouds?
Good question. So how do tornadoes break things if they start off as clouds? We're going to let Djordje tackle that one. Go ahead.
That's a very good question. Kids usually ask the most challenging questions. Well, tornadoes descend from clouds, but they are fast-moving air, just like any wind, but just much stronger. And, of course, there is a curvature in that wind. But if you take a very strong fan and you put something like sunglasses, that fan will blow away your sunglasses. tornadoes are just like that, but the winds, the fast-moving air, is fast enough to cause damage to houses, as we just heard in this story. So clouds produce tornadoes, but tornadoes are air, just like any other air.
Did that answer your question, Delia?
Yeah.
Okay, good. Did you have anything else that you wanted to ask?
No.
Okay, well, take care. Thanks for your question.
Thank you.
Bye-bye.
Bye.
We were talking earlier about the Northern Tornadoes Project. And so after the tornadoes hit at Mirabel and in Barrhaven, they were out on the ground. And so just yesterday, we actually heard that they found evidence of a second tornado that had hit in Quebec. And that was in the Lanaudière. How is it they would have discovered that second tornado?
So one way is that somebody maybe saw it and said, look, there was something that is similar to tornado, and they heard about it and they went to investigate. I do not know exactly, but I'm telling you what might have happened. Other option is they checked the area using satellite images, and then there was a particular part of the area that looked different, and by different, like there might be some damage that was not there before storm. And thirdly, researchers can see pattern of damage that is associated with tornadoes. If we have downbursts, for example, these are strong downdrafts from cloud that hit the surface, spread radially. Well, spread radially means also damage is kind of, if you have fallen trees, they fall radially out. Tornadoes, as they rotate and move, there is a particular spiraling-like pattern of damage that you can observe.
Okay. And, you know, if the researchers know generally the direction that the tornado has come, are they already looking at satellite imagery to see if there's ones that perhaps weren't reported or maybe not detected, just to see like what the terrain looks like? Because obviously in Quebec we have a lot of areas that are heavily forested. Yeah.
Well, they use the help of science, and that's that tornadoes had to be associated with cloud, with storm. So they follow the path of the storm, and then they investigate. So Canada is a beautiful, huge country. You cannot just every day scan whole country.
Correct, yeah.
So you check where are storms, and then you narrow down your search. So you follow the path of the storm. If you see something suspicious in terms of damage, well, then maybe that's worth additional check. You can contact people that lived there to see if they maybe saw a tornado, but nobody reported, and something like that.
You said in the U.S. that, you know, the U.S. was doing detection like this and having teams go out, you know, way back in the 1950s. Is there like a tip line that people can call, or where, like, now that they know that this group exists, that they send in, you know, calls to them saying, hey, we saw this?
Yes, there is. On their website, I do not know, unfortunately, phone number. I don't work for them.
No, but I'm saying it's like a tip line.
Northern Tornado Project, Tornado Project, there is a nice website, and over there they even have, I remember, you can click and say, report a tornado.
Neat. That is super neat. Well, today we're talking about all things tornadoes, and we're taking your questions if you have them, or perhaps even your experience with a tornado if one has touched down in your area. You can give us a call at 514-597-4500 or on the text line 514-566-9066. After the break, we're going to be speaking to a storm chaser, but first, the news. Thanks, Simon. Welcome back to Radio Noon. I'm Leah Hendry, filling in for Sean Appel. And today for the hour, we're joined by Djordje Romanic, who is an assistant professor at McGill University in the Department of Atmospheric and Oceanic Sciences. He is here to take all your questions about tornadoes. And we actually have a question for you that came in on the text line. It's a question about prevention. It says, I live in an apartment on the 5th floor of a 7-floor apartment building, since we're getting this dangerous weather more frequently.
I would say no. Probability of a tornado hitting a particular location is extremely, extremely low. And there is really no need to modify life to accommodate that phenomenon that really most likely none of us will experience. Now, most likely means not everybody. So, but still, if you take cost benefits, so to speak, if you balance positives and negatives of modifying house or something like that for these types of things, then probably it's not worth it. What is worth is having safer houses, buildings, apartments, but doing some small modifications on your own, probably not worth it.
And another text question is, does lightning mean that it will be followed by a tornado? Is that necessarily? No. Lightning can exist by itself?
Yes, no. There is no strong relationship between lightning and tornadoes. Lightning are way more frequent. Pretty much every supercell thunderstorm will produce lightning. Now, there is one relationship. Relationship is that both types of clouds are producing lightning and tornadoes.
Interesting. Okay.
These are cumulonimbus clouds, as I said. But having lightning doesn't mean there will be tornado.
Okay, well, thank you. And for the hour, we're joined by Djordje Romanic. He's an assistant professor in the Department of Atmospheric and Oceanic Sciences at McGill. And a couple questions. First of all, a texter asked, why does the sky go green? I guess, during or after we see some kind of strange color sometimes in the sky when there's a tornado?
I've received that question before, but I've never seen. Also, it is not the best idea to shelter under passes. The reason is there is a local intensification of wind speed due to channeling effect of the overpass, and there is also a very high suction that can intensify in these conditions and cause problems.
I mean, you heard Marc Romier from Quebec Vortex talking about storm chasing. What do you think of this? Is this something that you would want to be part of? And what precautions, I guess, would you kind of warn people about if this was something that they were thinking of doing?
So I do research on thunderstorms and tornadoes, but I've never seen a tornado with my own eye. Would I like to see a tornado? Would I like to chase these monsters? Maybe I can answer in the other way. You see, nuclear bomb that was thrown in World War II had energy 10 to power 13 joules. That is 1 followed by 13 zeros. Storm, average storm, not strong, average storm has energy 10 to 15 joules. If this doesn't make you study atmospheric sciences, I don't know what. So you have storm phenomenon. Maybe not.
Yeah, and as you mentioned earlier, there's also, you mentioned that
in Texas Tech University in Lubbock, Texas, and over there they have a facility where they test how flying debris is behaving in a tornado. And they do it by having a big gun, and they shoot objects. Wow. And there is a target, and then, they have very high-speed cameras and all that, so they analyze that. But seeing that with your eyes, how fast a wooden plank is hitting a target, I couldn't believe it. If that was a person, well, that's the end of that day. Mm-hmm. So it's not worth it.
Yeah, don't underestimate this. One of the things that we heard earlier was some tape from Ottawa in the Barrhaven suburb about how people felt after the tornado that hit last Thursday. And you could hear that, the woman was recounting how scared her son had been, how scared that her mother was. I just want to go back to the tape that we heard from Ottawa, because we were obviously hearing about some of the damage that had occurred with some of the homes that got hit there. Since the winds from tornadoes are so dangerous, how are cities making changes, I guess, to the way that buildings are constructed?
So all buildings in this country and pretty much all countries around the world have to be built to sustain certain wind speed. And that is based on the so-called return period of certain high winds. How often certain high winds happen over this region, and then buildings need to be able to resist these speeds. The problem with tornadoes is that, as I said, they are wind speeds, wind field in a tornado is completely different from straight line wind. It's very twisted, very turbulent, and also there is pressure suction. So building codes that we have to follow to build our structures to resist straight line winds are not always designed to protect us against tornadoes. Currently, that is very hot topic in research, and there are so many papers using numerical models, wind tunnels, damage observations that try to address that question and propose how to adjust building codes to have structures more resilient to tornadoes.
Do you find that, based on the research that you've seen, that Canadian cities are taking this seriously in terms of what it is that they're approving for future projects?
I think so. We have very good researchers in this country related to tornadoes. Now, in building codes, there is still no provision in building codes to design something to resist tornadoes, except some special structures, maybe nuclear power plants, some dams or so. In the United States, they are now introducing some recommendations for tornado-prone regions that should be followed. We still do not have that in Canada. Now, that doesn't mean we're doing worse. We have United States of America receives 1,000 to 1,200 tornadoes per year. We receive 100.
Yeah, big difference.
So there is no sense that we have the same level of building codes for tornadoes as them.
Okay, good point. I mean, there's different research that's out there about, you mentioned like the 80 to 100 tornadoes that we get here in Canada, but just to discuss in the last couple of minutes that we have, are we getting more tornadoes, or will climate change potentially trigger more? Like, how worried should we be?
Not very worried. Okay, let's be optimistic here in the last 5 minutes.
Okay, I like optimism. Go ahead.
So the thing is, climate change will result in global warming. But the very important term here is global. Locally, there will be big differences. Now, in Canada, we experience, research shows, climate change effects at the double rate of the rest of the world. Now, how is that going to affect tornadoes? Impossible to answer. There is different contradicting results. Research suggests that we might have, in the future, more environments prone to severe thunderstorms. But not all severe thunderstorms form tornadoes. So it suggests we will have more precipitation, heavy precipitations. But are we going to have supercell cumulonimbus clouds capable of creating tornadoes? It's not scientific, to be honest, to say yes or no, because we just don't know. We don't even know. We don't have theory of tornado formation. And how can I now say in 2075 if we are going to have more than now? We do see increase in the number of tornadoes, but one have to be careful because that's also associated with better measurement system, better reporting, what we talked at the beginning of this program. So that's artificial trend most of the time. It's not natural trend. Again, in the US, when they did serious analysis now, they saw that there is no significant trend in tornado occurrence across that country.
Mm-hmm. Okay, well, I'm going to stick with your optimism and hope that we just stick around that 80 to 100. Djordje Romanic, thank you so much for joining us today. I really appreciate you taking the time to explain this so thoroughly.
It was my pleasure. I had a great time.
Thank you.